Welcome back, everyone. If you're just wrapping up our previous lesson, Capstone Build Small Rust Program for Solana, seriously, take a bow. You've already gotten your hands dirty writing actual Rust code, handling references, and wiring up those small command line tools. Well, today we're going to take that exact same Rust knowledge and apply it directly to the blockchain. As part of our broader Programming with Solana track, we are diving deep into the Building Solana Program Entry Points module. This specific Forge College explainer kicks off our Introduction to Solana Program Entry Points with today's main event, the Overview of Program Entry Points. If you've ever wondered how a Solana program actually wakes up and starts doing work, you are in exactly the right place. Let's get into it. Here is our game plan for today. We'll start with a quick welcome to the front door, dissect the actual anatomy of an entry point, and then run through the bouncer's checklist. After that, we'll cover how to dispatch traffic, and finally, wrap things up with the absolute golden rules for your entry point.
All right, let's jump straight into Section 1, Welcome to the Front Door, the program's entrance.
So just like every standalone Rust application needs a main function to, actually start running, a Solana program needs a predictable front door to knock on. Formally speaking, an entry point is a highly specialized Rust function with a fixed, unchangeable signature that the Solana runtime calls. And here's the cool part. Unlike your command line tools where a user is manually typing in arguments, in Solana, the validator automatically bundles up the transaction and the runtime just drops the parameters right into your entry point's lap. The best way to think about this? Your entry point is basically the strictest bouncer at an exclusive, high-end VIP club. Think about it. The bouncer doesn't mix the drinks, they definitely aren't the DJ, and they are absolutely not sweeping up the floor at 3 a.m. Their sole, extremely important job is to stand at the door, meticulously check IDs, and make sure absolutely no one is sneaking in through the kitchen. If and only if everything checks out perfectly, they unclip the velvet rope and let you in. Your Solana entry point operates exactly the same way.
Moving right along the Section 2, Anatomy of the Entry Point, the Fixed Signature.
To do their job, the Solana entry point must answer 3 very specific questions. It's kind of like a holy trinity of blockchain validation. First question, where are we? That's your program underscore ID, passed in as a reference to a bub key. This confirms the actual ownership of the program executing the code and makes sure we aren't getting confused with some other program. Second question, who is here? That's your accounts parameter, passing through as an array slice of account info. It literally lists every single account trying to get into the club. And the third question, what do they actually want to do once they're inside? That is the instruction underscore data, which arrives as a raw byte slice. This holds the instruction selector and any other serialized parameters. So remember, where, who, and what. Now, it is absolutely crucial to understand exactly where the bouncer's job ends and the bartender's job begins. Your entry point handles the structural stuff, checking the IDs, deserializing the data, and pointing people down the right hallway. That's it. Your internal handlers, the bartenders, take over from there to handle the domain logic, actually mutate the state, and mix the drinks. Let's be real. If your bouncer is trying to do complex math and mix cocktails at the door, the line to get into your club is going to be wrapped around the block. Keep them separated.
Let's break this process down in Section 3, the bouncer's checklist, the lifecycle of a call.
So, what is the exact sequence of events when a transaction shows up? Well, step 1 is routing and invocation. A transaction hits a validator node, the runtime preps those 3 parameters we just talked about, and calls your entry point. Step 2 is structural validation. This is where our bouncer does those quick, defensive checks at the door. Step 3 is deserialization and dispatch. The bouncer reads the raw byte data, translates it into a language the club actually understands, and routes the request. Step 4, handler execution. Finally, the internal domain logic does the heavy lifting. And step 5, the handler finishes up and hands a program result back to the entry point, which reports a simple success or failure back to the runtime. Let's zoom in on step 2 for just a second, because those structural validation checks are fascinating. What exactly is the bouncer looking for? First, they verify the exact number of accounts. If an instruction says it needs 3 accounts, and someone tries to slide in with 2, nope, kick them out. They confirm all required accounts are present. They check that the specific accounts are actually owned by the right program. They validate rent exemption, and they check the required signer flags. Basically asking, did the person who actually owns these funds sign this transaction? If literally any of these checks fail, the bouncer doesn't negotiate. They don't ask nicely, they immediately toss the transaction out on the sidewalk with an error.
Okay, moving to Section 4, dispatching traffic, translating raw bytes.
Once the bouncer confirms your ID is legit, they still need to figure out why you're actually here. Remember that third parameter, instruction data? It shows up at the door as a slice of raw bytes. To the program, it just looks like a string of absolute gibberish. So the entry point has to act as a translator, carefully taking those raw bytes and deserializing them into a structured, typed command that your Rust code can actually read and work with.
Building this traffic cop in Rust is surprisingly clean. We follow a simple three-step workflow. First, we extract a tag, which is usually just the very first byte of that data slice, using a method like split first. Second, we use a standard Rust match statement to look at that tag. Let's say tag 0 means they want to initialize an account, and tag 1 means they want to transfer funds. Third, based on that exact match, we route the traffic to the specific domain handler. Tag 0 goes straight down the hall to the process init function. Tag 1 goes straight to the process transfer function. It's incredibly clean, organized, and it keeps the entry point nice and lightweight.
But hey, what happens if the data is just totally malformed? What if someone hands the bouncer a fake ID, like a tag of 99, but our club only accepts zeros and ones? The absolute golden rule here is to fail fast. The entry point must return an explicit program error value to abort the execution immediately. Do not, I repeat, do not let bad data seep into your internal handlers. Returning an explicit, clear error code right at the door makes your program predictable, and honestly, it makes on-chain debugging infinitely easier for both you and the users trying to interact with your program.
Finally, let's wrap up with Section 5, Entry Point Rules, Best Practices.
Listen, if you only remember one single thing from this entire explainer, let it be this mnemonic rule of 3. Validate early, deserialize deterministically, and dispatch cleanly. I'm actually going to say that one more time because it really is that critical. Validate early, deserialize deterministically, dispatch cleanly. If you stick to this discipline, you're going to drastically reduce runtime surprises, avoid nasty security vulnerabilities, and you'll make unit testing your individual handlers an absolute breeze.
I'm going to leave you with this final, somewhat provocative thought. Your entry point is an amazing bouncer. Truly. But if the entry point is the front door, are your internal handlers accidentally leaving the back door open? Remember, the entry point is only your first line of defense. The actual domain logic happening inside still needs to be bulletproof. To learn exactly how to secure those internal handlers and to dive way deeper into all things Web3, make sure you head over and visit Forge College. This has been a Forge College Explainer. Thank you so much for hanging out and learning with me today, and I will see you in the next one.